We'll proceed in vector and energy calculus. Vector and energy calculus, vector and commercial calculus. We are into professional calculus now. Professional calculus in a way that how we can use vector terminology in professional calculus. Professional calculus, we started with many things. We came to curling factor and then we are into flux. Flux. Flux means if there is a velocity of liquid passing through a surface, then how much is the volume of the liquid that is coming out of the surface? Velocity vector dot product with the area vector. If velocity of the liquid is hitting the surface and surface vector is perpendicular to the surface, if this is the surface, then surface vector is not along the surface because there will be too many vectors. Why surface vector? Okay, so we have talked many things. We'll take some examples today. I believe vector and energy calculus, commercial calculus, we have done kind of thing. So nothing is there. Divergence is the main thing. So we will take some examples or something like that. Okay, someone would say, if this is a curve, this is a straight curve. What is the vector representation of it? Vector representation is a vector that is along the line. Okay, tell me what is the vector representation of this? Then vector representation of this is along the line. So everywhere vector is tangent at the line. So there are many vectors, a group bunch of vectors, they would represent this line. How many? Infinite. Because every moment line is turning. Actually, a straight line can be represented by a single vector. Vector is always straight. Vector is always straight. A direction with magnitude is a vector. Energy which has a direction and magnitude is vector. If energy is moving in a straight line, then it can be described as single numeric vector. But if energy is moving like this, then since vector is a straight line, it cannot be described in a single vector. If line is like this, then every moment line is taking curve. If someone sees it from here to here, it is a straight line. Then only one vector would represent this. After this, vector would take kind of angle. I mean, vector would take a deviation. Vector cannot take deviation. In that sense, there will infinite number of vectors that will represent this line. That is, vector should be along the line. So it will be algebraic vector. Why I said infinite? If it is algebraic vector means a vector whose x component, y component, and z component are algebra, not numeric. Like 2i plus 3j is a numeric vector and it is a straight line. Whereas minus yi plus xj is an algebraic vector. Keep changing value of y and x, keep getting new vector, bunch of vectors. That will be that actually minus yi plus xj. If this is xy plane, it represents a circular vector. So vector can be non-linear also. Then it is set of vector can be represented through algebraic vector. That is the scenario. So vector field dot product with the area vector is the net flux, net volume coming out of the area surface. If this is the area and this is the liquid that is passing through this area, how much is the volume that is coming out of the surface? Volume per second, meter cube per second. Velocity of the liquid is meter per second and area is meter square, meter cube per second. Velocity vector dot product with the area vector. Why area vector is the question mark? If I have an area, okay, okay, if I have a curve, then the vector representation of curve is along the curve line, Makes sense? But if I have a surface, then vector representation is not along the surface because if I take the surface and do the vector representation, then there will be many vectors that will come on this surface, many vectors, 360 degrees. That is not representation of the surface. It is not a line. In that sense, the vector that is perpendicular to the surface is said as the area vector. Area vector is a vector that is perpendicular to the area. Curve vector is a vector which is along the curve. Makes sense? Okay, there is a 3D vector also. Area vector is a 2D vector. There is a 3D vector also. I believe it is called triple scalar product, something like that. Triple product or something like that. A cross B. A cross B. A vector cross B vector gives the area vector. A cross B dot product with the C, 3 dimension. This is called a scalar product, dot product or something like that. That is the volume vector. There can be n dimensional vector also. So velocity vector dot product with the area vector gives the net flux, that is net volume of liquid that is coming out. Anyway, what we have seen, the fundamental of the flux as far as energy is concerned. If there is a velocity, if there is a velocity and it is passing through a surface, okay, this surface belongs to a volume. Consider this surface belongs to a volume. We have taken the example, right? A surface belongs to a volume. Hop, 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 hop. Okay, this is a power bank. This is a power bank, and electric, and there is a velocity. There is a electric vector, electromagnetic radiation. There is nothing that is weightless. People think that this is a weighted. It has a weight. It has a weight, whereas electromagnetic radiation is like something that cannot be seen. So everything has a weight. Sunlight also has a weight. Sunlight is not weightless. If sun is radiating energy through the sunlight has weight. Sunlight is not weightless. Sound is not weightless. All these waves, electromagnetic radiation has weight. Consider electromagnetic radiation is a electric is a liquid, electromagnetic liquid. A liquid is flowing like this. It is passing this surface, first surface. Then it is passing the second surface. Okay, if this velocity keep changing, when it is hitting this boundary, then velocity is x. Then when it is coming out of this boundary, then velocity is x plus y. Y got added in the velocity. Consider this is x-axis. Consider this is x-axis, this is origin, this is origin, this is x-axis, then this is hop, 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 hop. This is minus x-axis, this is z-axis, this is minus z-axis, this is y-axis, this is minus y-axis. In that case, if there is a liquid that is passing through this surface, then liquid has velocity x. When it is coming out, I'll make like this. I believe it is better. Consider this as a surface. There is a surface like this. There is a surface like this. This surface area is same as this surface area. There is a liquid that is passing this surface area, and liquid is coming out of this surface area. Okay, otherwise this surface area, okay, this is not flat. So this surface area has so there are four kind of surfaces. One surface is there are two kind of surfaces. One surface vector is along x-axis. Another surface vector is along minus x-axis. Otherwise, this is a round kind of thing. If I take the area vector that is perpendicular, then it is it is like this. This is YZ plane. This vector, this area vector of this is in YZ plane. YZ plane, x-axis minus x-axis. If liquid is flowing towards x-axis, YZ plane area vector is exact perpendicular to the velocity. The net flux means how much water, how much liquid is coming out. If liquid is entering from here, then liquid will come out from here. Liquid will come out from the surfaces also. But the surface vector area vector is in YZ plane. YZ plane is exactly perpendicular to the x-axis. In that sense, it the kind of the liquid that is going in x-axis, it makes 90 degree with the yz plane, any vector in the yz plane. If it is 90 degree, means flux will be zero in this surface. Means no liquid will come out from here. Whatever the liquid is going, it will come out from here. Okay. In that sense, if liquid is velocity is x and coming out liquid velocity is x plus y, then here if this area is a, then liquid that is entering through this area is x into a meter cube per second. Liquid that is coming out from here is x plus y bracket closed into a liquid. Where from the extra liquid came into the picture? Means someone is mixing liquid inside this. If someone is mixing liquid inside this, so consider it is centered at the origin. So at the origin or along the x-axis, someone there is a point where liquid is gushing, and then it is adding to the velocity, and velocity is becoming x plus y. Okay, then this proves that the velocity of the liquid is changing along the x-axis. And when I'm seeing through this surface, by that time it becomes x plus y. X plus yi. Earlier velocity of the liquid was xi, it becomes x plus yi. Means if the velocity, if I describe velocity as f vector, f, f is the velocity of the liquid, then df by dx is there. Change in f along the x-axis is seen. df by dx means if I make 1 unit of change along x-axis, how many unit of f is changing, velocity is changing. df by dx. Since f is velocity vector is changing, so df by dx is there. If it is entering from x-axis, it is entering the surface at x velocity, coming out with x velocity, then there is no change in the velocity. df by dx is 0. If it is entering with x and coming out with x minus y, then again there is a liquid source is there inside that. The liquid source is not emanating liquid, rather than it is sucking the liquid. That's why liquid velocity is decreasing. So this is called divergence point. Divergence point is a point where energy is either liberated or energy is sucked. If energy is liberated, that point is called positive energy divergence. If energy is sucked, then that point is called negative energy divergence or hole. Energy is dripping from there or energy being pushed out from there. If energy is being pushed out from there, then it is called positive divergence at that point. If energy is sucked from there, then it is called negative divergence at that point. What is the formula of divergence? One formula of divergence. What is divergence of this? Okay, divergence of this against the velocity f. Then calculate the flux that is coming out of it. If flux here and flux here are same, then net flux is 0, because this surface area has direction along the minus x-axis. This surface area direction has plus x-axis. If I add along this, there is no flux, 90 degree. If velocity entering is same as velocity in exiting, then flux entering is same as flux exiting, whereas this flux direction is minus I, flux direction is plus I, then the net flux is 0. If it is not 0, then df by dx is there. Net divergence. Divergence means divergence at a point. There is a point inside this, at that point energy is getting mixed. There is energy that is going inside it, and it is making the liquid velocity higher. The liquid that is flowing here, coming from here, it is because of some energy source is there. Because of that energy source, electromagnetic liquid is coming and it is passing like this. At the center, I made another electromagnetic source out there. It is adding to the liquid and making the velocity grow. In that fashion, there is a flux. Whatever the flux is, divided by the volume of this is called flux density. Flux density means per unit of this volume contributes how much flux. This is called flux density. Flux density means whatever, if I have a volume, suppose Okay, if there is a liquid that is passing through this volume coming out of this, then how much is the flux? Flux means how much is the liquid that is come oozing out from the surface. Okay, if you watch very clearly, then from this side, it's this sphere, up, up, this sphere, this sphere has two sides. One, you can see, one is lighted and one is dark. This side, if liquid is coming from this surface, the liquid would enter. From this side, liquid would come out. Okay, then there is a chance that the liquid that is entering, liquid that is coming out, they would be same. Net flux is zero. Flux means how much is the liquid coming out of the surface. But one side liquid is coming out of the surface, other side liquid is entering into the surface. No, liquid should come out of the full surface. That is the net flux if it is not zero. Or all from all side it is sucking the liquid. Okay, this is a sponge, and I squeeze the sponge completely. There is nothing nice. Now I throw in a water. It sucks energy from all sides as water liquid or any liquid. Then, or there is a electromagnetic wave is there, or electromagnetic radiation is there, electromagnetic liquid is there. If I press it, it sucks it from all directions, from all surface. Then it has flux as negative. But if I just keep it and it is radiating energy, then it has flux positive. From surface, it is going out. Whatever is the flux, divide it by the volume is called flux density. Flux density means per unit volume of this, how much is flux generated. If this has volume as V, and flux is F, flux is velocity vector dot area vector. It is considered that is flux is F. F is denoted as velocity vector. Flux is X. Flux is alpha. Flux is alpha generated for this volume V. Alpha by V is the net flux coming out per unit volume. That is also called flux density, or 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 the divergence of it. There are two different things: flux density, divergence. Flux density means how much flux is coming out of the surface divided by the volume that surface makes. Per unit volume, how much is the flux that is coming out? This is called flux density. Similarly, the example I gave, if the flux of this is positive, if velocity is coming, liquid velocity is coming like this and coming out of this, and this side velocity is more, then there is change in velocity that is seen. Flux is there. There is a chance that flux will not be there when it is entering here velocity and same velocity is coming out. Net flux is zero. This is negative, this is positive, zero. But if flux is there, then flux divided by the volume is the flux density. Or how much is the velocity is changing when it is going along x-axis, df by dx. That is also flux density. Flux density is net flux coming out of the surface divided by the volume. Okay, knowingly, unknowingly, it is same as df by dx. The change in the velocity along the x-axis, this is same. Okay, but it is along the y-axis also, z-axis also. Then add it. The net flux density coming out of a surface of a volume is flux of the surface divided by the volume is same as df by dx, or df1. If velocity vector has f1, f2, f3 are its x, y, z component, then df1 by dx plus df2 by dy plus df3 by dz. Whatever it comes, that is called divergence. It is called divergence because if velocity of this is changing from this surface to this surface, how much velocity change? This velocity change is df by dx. Now per unit x, how much it is changing? This change is directly proportional to I have put an energy source inside it, and that energy source is releasing liquid. Because of that only speed is growing. What is the divergence of the electric source? What is the power of the electric source? Power of the electric source is directly proportional to the change in the velocity of the liquid IC per unit change in x-axis. If df by dx is high, high means here the liquid is entering with 1 meter per second, coming out with 100 meter per second. Means df by dx is very high. Per unit change along x-axis brings high unit change in velocity. That talks about the divergence of a point at a point where it is mixing the liquid. There the speed at which it is mixing the liquid is very high. Divergence at that point is very very high. That is df by dx is very high. So net divergence is divergence and flux density are same thing. Flux density is flux divided by the volume. It is same as df1 by dx plus df2 by dy plus df3 by dz. Okay, bigger than this is if someone knows the divergence or someone knows the flux density, he can calculate back the flux. From the flux, someone can calculate flux density, net flux by the volume, or someone has the velocity vector then df1 by dx plus df2 by dy plus df3 by dz. If that is the divergence, that is flux density, same thing. Then flux density multiplied by the volume is the net flux. We have done it. So df1 by dx may resolve into a xyz factor. Df2 by dy may resolve into algebraic equation in xyz. Df3 by dz may resolve into algebraic equation of xyz possible. Means df1 by dx plus df2 by dy plus df3 by dz, which is flux density or divergence, it is not a vector, but it may result into algebraic equation of xyz where xyz are independent to each other. If I say I have a divergence dot product with the volume, I'm sorry, divergence multiplying it with the volume give the flux back. If I know divergence of a velocity vector, divergence of a velocity vector, if I multiply with this volume, then I can calculate how much flux will come out of it. Or if I know the flux that is coming out of it, flux, then calculate the net flux, divide it by the volume, you get the flux density or divergence. Or if you have divergence or flux density, multiply it by the volume, it will give the net flux. But problem here is that if divergence or flux density is an integer, it is a number, then you can silently multiply by the volume, silently. Then it is all right. It will give you the net flux. But if it is not a number, it is a kind of it is kind of algebraic equation. Then there is x, y, z is involved. Then it is what is the net divergence? That is a algebraic equation in x, y, z. If anything in x, y, z, that is called divergence. Divergence into volume. Divergence into volume give the net flux. Divergence is nothing but it is divergence. If we talk, this is called flux density. What is flux density? Flux density means if I take a 3D and if I know the flux density inside it, means at each point, what is the density? If you multiply all this density with the volume, it will give you the net flux. Okay, but density may not be constant. If it is constant, then silently you can multiply by the volume to get the net flux coming out of the surface. If it is not constant, consider this is xy plane. This is x-axis, this is y-axis, this is z-axis, this is xy plane. Okay, now this is 3D. XY plane and Z makes 3D. Consider that I have density. Density means at each point, if I take XY on XY plane and Z is the height. If I take XYZ, every point density is different. If every point density is same, just multiply it by the volume, you get the net flux. Net flux here, the density into volume is net weight. Density means weight per meter cube. Kg per meter cube is also called density. In other terms, what is the weight of this? 100 kg. What is the volume of this? volume of this, that is 50 meter per 50 meter cube. This means the density is 2 kg per meter cube. If I have a iron, solid iron 3D, and weight is 50 kg, weight is 100 kg, and its volume is 50 meter cube, then the density is 2 kg per meter cube. Okay, if I say the density of this material is 2 kg per meter cube, and then what is its weight? Tell me the dimension. It is 50 meter cube, then 100 kg is the weight. Anyone would say, what is the density? Density is x into y into z. What do you mean x into y into z? That is the density. It means it means if I take this 3D and this is the origin, from origin it is kept like this. This is x-axis, this is y-axis, this is z-axis. At the origin, that is x comma y comma z, 0 comma 0. At that point, there is no density at all. It is completely vacuum. But if I go along x-axis, y-axis, z-axis, or all in three directions, the density keep on growing. Now tell me what is its weight when dimension is 1 meter by 1 meter by 1 meter? This is a big question now. If the density is x into y into z, the way you move along x-axis, y-axis, z-axis, density will grow. Density is not uniform. It is not constant. Then tell me the total weight. Then direct multiplication will not work. What is the volume, that is x into y into z? X into y into z is the volume. For how much you want? I want for 1 meter into 1 meter by 1 meter. Volume is 1. 1 into 1 into 1. 1 into 1 into 1. And density is x, y, z. At 1, 1, 1, it will be 1 only. 1. 1 kg is the weight. Completely false. Okay. When the density is in algebra, when density is in algebra and you have a volume, you cannot multiply directly to get the weight. Then density into volume will not give you the weight. Density into d of volume will give you the weight. It will enter into integral calculus now, because density will termed as dependent component and dependent component. What is independent then? X, Y, Z are three independent components here. X, Y, Z are three independent components here. Then what is dependent? Density is dependent. At each point, density is different. Density is dependent upon X, Y, Z coordinate. If you keep changing X, Y, Z, density will be different. Density is dependent upon X, Y, Z. If someone is saying flux density into volume is giving the net flux, then flux density, if it is in algebra, then density is dependent component on x, y, z. If there is a multiplication that involves dependent and independent and it is algebra, then direct multiplication will not give the result. This is primitive calculus. You have to do multiplication with the d of the volume. Now it will become density function, that is fxyz, function over xyz, that is density, into d of the volume. D of the volume is dx dy dz, and then integrate it over the full volume, that is x is from 0 to 1, y is from 0 to 1, z is from 0 to 1. This will give the net volume. Tell me how much it is. Then x, if I integrate with z first, then it becomes z square by 2. X into y into z square by 2. 0 to 1, 1 by 2. 1 by 2 you keep outside. X into y square by 2, again it will become 1 by 2, keep outside. X is x square by 2, again 0 to 1, 1. 1 by 8 kg is the net weight. 1 by 8 kg is the net weight, not 1 kg people were thinking. Okay, this is if you have density function and you want net weight. If you have flux density and if you want net flux, then flux density into volume will give the net flux, but not direct the. Okay, okay, you said like this, right? Okay, now my flux density is 2. Now tell me, flux density is 2 and volume is 1 by 1 by 1. I do direct multiplication and I get 2 kg. With your integration, some different result will come. Okay, so my approach is better directly multiply it. Okay, let's try with integration only. X, okay, the the function density function is 2. Everywhere it is 2. 2 dx dy dz. Now dz is z 0 to 1, 1. Y 0 to 1, 1. Dx is x 0 to 1. 1 into 1 into 1 into 2, 2 only. So then this proves that numerical multiplication is a special case of integration. Integration is a big thing. And normal algebra is a special case of a vector. Vector is a big thing. Vector to algebra to numeric. I won't say that much a difference, but the integral calculus is superset of normal multiplication. Differentiation is superset of normal division. Differentiation talks about different division of algebra where one component is dependent upon another. X by x, x by x, x by x is 1. X by x is not 1 if one x is dependent upon another x. If the numerator x is if numerator x is independent and denominator x is dependent, then it will become 1 by x dx. I believe that will become minus 1 by x square. Whereas x by x is simple 1 if both are independent to each other. That is integral calculus. Anyway, now we have learned that to get the flux out of flux density is flux density dot d of volume. Now anyone is free to use any coordinate system, Cartesian, whatever it is. We will quickly do one example. Consider I have a divergence, I have a velocity field that is minus xi plus zk, minus xi plus zk. Means there is a liquid along minus xi means in the x-axis the liquid is going toward the origin. Please watch previous video or previous to previous video. A liquid equation in minus xi means liquid is coming from x-axis and minus x-axis it is coming at the center, plus zk. From center the liquid is going out in z direction. Okay, then what is the divergence? Divergence at the origin. Divergence means at the origin, if there is an energy source, how much that energy source is contributing in this liquid. If liquid is coming at minus x and going out as z, then there is it is behaving like a router. That origin point energy source behaving just like a router. It is not adding anything there. In that sense, minus xi plus zk becomes minus 1 plus 1. That is 0. There is no divergence there. Anyway, now question arises is if divergence is 0, if divergence is 0, 0, it is called divergence free vector field. Divergence is free velocity field. It is 0. Can someone prove that for any closed region, the flux will also be 0? If divergence is 0, then for any closed surface, divergence, the net flux will be 0. Now let's consider the velocity vector is minus xi plus zk df1 by dx plus df2 by dy plus df3 by dz. If you add minus 1 plus 0 plus 1, 0. Now let's have a cube. Let's have a small cube which side is 1 into 1 into 1. Okay, and cube is centered at a point that is 1 comma 0. There is a there is okay okay we will do that. Let's consider there is a cube. So all sides are equal length 1 by 1 by 1. It is centered at 1 comma 0 comma 0. If that is the case, the left side is 1 by 2, right side is 3 by 2, and then on y direction it is 1 by 2 and minus y direction it is minus 1 by 2. Z is 1 by 2 and minus 1 by 2. That is the cube. Now against this velocity, calculate the net flux. Okay, net flux, if I go with the flux density into volume, then it is anyway 0. But let's calculate. Can someone prove it that if the flux density is 0, divergence is 0, then the for a vector field f, if divergence is 0, then f dot dA vector will also be 0. Now let's calculate it. F vector is minus xi plus yj dot product with the area vector. If I take these two area, this is x-axis, I take these two area. One surface is in yz plane, another surface also in yz plane. One surface is at x equal to 1 by 2, this cube is centered at 1. Another surface is at 3 by 2. At this surface, how much is the flux? At this surface, the flux is, now the velocity field is minus xi plus zk, minus xi plus zk. This surface area vector is along the minus I. So it becomes d delta y delta z, delta y delta z minus I. dy dz minus I, this is the area vector. Now minus xi plus zk dot product with the dy dz minus I. Okay, minus xi minus I at x equal to 1 by 2. It becomes minus 1 by 2 minus 1 by 2I. Zk will go away. Zk will go away because it is only I here. Minus 1 by 2I dot product with minus I. It becomes 1 by 2. 1 by 2. 1 by 2 dy dz, where z is 0 to 1, z is minus half to half, y is minus half to half. It becomes 1 into 1 into 1, 1 into 1 into 1 by 2. So left side, the flux will be 1 by 2. Let's calculate right side. Right side again minus xi means 3 by minus 3 by 2I dot product with, now if I take surface, this surface is in minus x direction, this surface is in x direction. So it will be dy dz I vector, dy dz I vector and minus 3 by 2 I. It becomes minus 3 by 2 dy dz. dy dz becomes 1 minus 3 by 2 and this side 1 by 2. Net becomes minus 1. Minus 3 by 2 plus 1 by 2 minus 1. So this side the net flux is minus 1. Minus 1. Let's calculate these two sides. One is y equal to minus 1 by 2. One is y equal to 1 by 2. This is xz plane. Dx dz plane along the j direction. There is no j here. There is no j here. Minus xi plus zk. There is no j here. So this side there is no flux at all. Top side, let's see. Z is minus half and other is half. Let's calculate the flux of the minus 1 by 2. Now the equation is minus xi plus zk. And this will become xy plane. Dx dy, if I take lower side, then vector will be minus z direction. Dx dy minus z. Minus xi will go away, dot product. Only zk will remain there. Zk at minus 1 by 2. Minus 1 by 2 k vector. Minus 1 by 2 k vector dot product with dx di minus k vector. Minus minus plus 1 by 2. 1 by 2, 1 by 2 dx dy. Same is x is from whatever, x is from half to 3 by 2, it will become 1 1. This side the flux will be 1. Let's calculate the flux on top. Zk, flux on the top, okay, flux on the top. So, I'm sorry, we'll try again. The bottom one is whatever it is. It is zk. Z is minus half k, minus half k, and that side it is in minus k direction. Okay, it became plus 1 by 2. Okay, let's go top. Zk, it is half. Z is half. Zk dot product with dx di k vector. It will become half 1. Along the x-axis, it was minus 1, if I remember well. Minus 1 plus 1, net flux is 0. Okay, now someone can keep this cubical cube center at the origin. But what is the biggest here? If I have a vector field velocity field whose divergence is zero, can someone prove that its flux calculation, that is velocity vector dot d area vector, will also be zero? Now someone can try with this only, minus xi plus zk for a sphere, not for a cubical side where I computed all six sides. For a sphere, this is assignment. The the velocity field is minus xi plus zk. Divergence of this is zero. Now this velocity field is applied to a surface that is spherical. This sphere is kept. This sphere has a radius 1 and it is centered at 2, 0, 0. One case. Another case is it is centered at the origin only. Let's find out at both places the net flux coming out of is zero. Third question is velocity vector is r vector divided by r to the power 3. Divergence again is zero. R vector divided by r to the power 3. Against that vector, try to find the flux for a cube and flux for a sphere centered at the origin, not centered at the origin, and see flux is indeed it is zero. Big question. Anyway, don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.